It takes many billions of years to create a galaxy like the Milky Way galaxy with 100 billion stars, many billions of years old.
For several decades, astronomers have been aware of the inevitable collision between the Milky Way and our neighboring Andromeda galaxy. These two immense cosmic structures have been hurtling towards each other at high speeds, driven by the irresistible force of gravity. Initially, scientists predicted that this collision would occur billions of years in the future. However, recent observations have upended these expectations. The James Webb Telescope, a cutting-edge instrument designed to explore the cosmos with unprecedented clarity, has transmitted a startling signal back to Earth. This signal indicates that the collision between the Milky Way and Andromeda is not a distant future event, but a current reality. The collision has already commenced, sending shockwaves through the scientific community and prompting urgent discussions about its potential consequences. Scientists are now urgently studying the nature of the collision and its likely impact on our galaxy, Earth, and the wider universe. They are working to comprehend the dynamics of this high-impact intergalactic event and to develop strategies for mitigating its effects. The signal sent by the James Webb Telescope likely comprises a wealth of data, including images, spectra, and measurements of celestial objects within the vicinity of the Milky Way and Andromeda. By analyzing this data, scientists can glean valuable insights into the nature of the collision, such as the speed and trajectory of the galaxies, the distribution of matter within them, and the formation of new structures as a result of the collision. As for the fate of Earth and our Milky Way galaxy, the consequences of the collision are complex and multifaceted. On one hand, the merger of galaxies can trigger intense bursts of star formation, leading to the creation of new stars and planetary systems. On the other hand, the gravitational interactions between the galaxies can disrupt the orbits of stars and planets, potentially causing celestial bodies to be flung into interstellar space or collide with each other. The ultimate outcome of the collision depends on numerous factors, including the mass and composition of the galaxies involved, the angle and velocity of their approach, and the presence of dark matter and other invisible components. While some regions of space may experience violent upheaval, others may remain relatively unaffected by the collision. In the midst of this cosmic drama, Earth occupies a tiny speck of space, a fragile oasis of life amidst the vast expanse of the universe. While the collision between the Milky Way and Andromeda will undoubtedly reshape the cosmic landscape, it is unlikely to pose an immediate threat to our planet. However, the long-term consequences of this collision remain a subject of intense scientific inquiry and speculation. In the coming years and decades, astronomers will continue to study the collision between the Milky Way and Andromeda, seeking to unravel its mysteries and understand its implications for the future of our galaxy and the universe as a whole. Through their efforts, we may gain new insights into the fundamental nature of the cosmos and our place within it. Scientists had long believed that Andromeda was significantly larger than the Milky Way. When observed from Earth, Andromeda appeared immense, leading to the assumption that it dwarfed our own galaxy. However, advancements in technology, particularly high-tech instruments like the James Webb Telescope, provided a clearer perspective. Scientists realized that Andromeda isn't much larger than the Milky Way. In fact, thanks to observations made by the James Webb Telescope, scientists discovered that the Milky Way is even larger in mass than previously thought. Galaxies are incredibly vast and complex systems, constantly evolving over cosmic timescales. Determining the precise mass of a galaxy is challenging because it encompasses everything from stars and planets to dust and dark matter. Even with sophisticated observatory instruments like the James Webb Telescope, accurately measuring Andromeda's mass remains elusive. However, these instruments do enable detailed observations of Andromeda, offering insights that were previously unattainable. Despite being 25 million light-years away, Andromeda is considered our next-door neighbor in cosmic terms. The massive scale of both Andromeda and the Milky Way diminishes the significance of this distance. However, their close proximity is just one aspect that makes Andromeda special. Andromeda shares numerous similarities with the Milky Way, despite being slightly younger. It measures an impressive 220,000 light-years across compared to the Milky Way's 100,000 light-years. Additionally, Andromeda is estimated to contain approximately 1 trillion stars, significantly more than the Milky Way's 400 billion stars. One remarkable feature of Andromeda is its supermassive black hole at the center, which is approximately 110 million times heavier than our Sun. This active galactic nucleus emits substantial amounts of light and radiation, making it a focal point of astronomical study. Globular clusters, tight groups of stars formed over billions of years, are another distinctive feature of Andromeda. With around 400 globular clusters, each containing thousands or even millions of stars, Andromeda boasts a rich concentration of stellar phenomena. Despite initial assumptions, the collision between the Milky Way and Andromeda may not necessarily result in the Milky Way suffering the most damage. Dark matter, an invisible and mysterious substance that pervades the universe, surrounds the Milky Way in a vast cloud measuring up to 2 million light-years across. This dark matter, though invisible, exerts a significant gravitational influence, potentially making the Milky Way as resistant and powerful during a collision as Andromeda. Dark matter's presence, though initially undetectable by conventional means, plays a crucial role in the universe's evolution and structure. Its discovery has reshaped our understanding of cosmic phenomena and continues to intrigue scientists as they unravel the mysteries of the cosmos. Scientists have given the cloud of dark matter surrounding the Milky Way the nickname dark matter halo. Andromeda also possesses its own dark matter halo, although it is considerably smaller. Dark matter, like regular matter, has mass. While the visible masses of stars and the supermassive black hole in Andromeda may suggest that it outweighs the Milky Way, the presence of the dark matter halo evens out the scales, making the two galaxies nearly equal in weight. Thus, determining a clear victor in a hypothetical galactic battle would be challenging. Andromeda's unique history adds further intrigue to its character. Astronomers believe that Andromeda is not merely a single galaxy, but rather a conglomerate of several smaller galaxies that have merged over time. These collisions occurring during the formation of Andromeda resulted in the explosion of stars and the dispersal of vast quantities of stardust. Approximately 8 billion years ago, Andromeda absorbed another galaxy, a process repeated 100 million years ago. This phenomenon, termed galactic cannibalism, has contributed to the formation of Andromeda's many globular clusters. While the concept of galactic cannibalism may sound gruesome, it is a fundamental aspect of cosmic evolution. Even the Milky Way has engaged in galactic cannibalism, having absorbed around 12 smaller galaxies over its 13 billion-year existence. Such interactions are integral to the formation and growth of large galaxies. Previous assumptions suggested that the Milky Way's acts of galactic cannibalism would precede its collision with Andromeda. However, data from the James Webb Telescope has revealed that this intergalactic clash will occur much sooner than anticipated. The collision between the Milky Way and Andromeda raises significant questions about the fate of our galaxy. Visualizing this collision as two colossal disks of light smashing into each other, causing explosions and the release of gases and stardust, may be misleading. In reality, even in densely populated galaxies like Andromeda, there is a significant amount of empty space between stars and planetary bodies. This means that collisions between individual celestial objects may be rare during the merger. Instead, the collision will likely involve a process of filling in gaps, where stars and planetary bodies from Andromeda and the Milky Way intermingle without directly colliding. This interaction will disrupt the balance and formations of both galaxies, potentially leading to reactions and rearrangements. One anticipated outcome of the collision is the transformation of the Milky Way from a spiral galaxy into an elliptical one. Spiral galaxies like the Milky Way and Andromeda have a disc-like shape with spiral arms, while elliptical galaxies have a smooth ellipsoidal shape. This transformation will result in a restructuring of the galaxy's structures and compositions, potentially altering the distribution of stars and other cosmic phenomena. Ultimately, the collision between the Milky Way and Andromeda offers a fascinating glimpse into the dynamic and ever-evolving nature of the cosmos. It underscores the complex interactions that shape galaxies and drive cosmic evolution on a grand scale. Indeed, scientists estimate that only 1 in every 10,000 galaxies are ring galaxies, but these rare formations can grow to become supergiants. Therefore, when Andromeda merges with the Milky Way, scientists predict that the resulting galaxy will likely be elliptical in shape. This prediction is reinforced by the observation that Andromeda itself appears to be transitioning towards an elliptical galaxy even before the collision occurs. Thus, the collision with our galaxy may accelerate this transformation, leading to the formation of a fully elliptical galaxy. Furthermore, the newly merged galaxy may undergo rearrangements, potentially hosting a mega black hole at its core, similar to the one found in Andromeda. It's not uncommon for spiral galaxies like Andromeda and the Milky Way to have black holes at their centers, which are believed to play a crucial role in maintaining galactic stability through their gravitational influence. The merging of black holes during the collision could trigger significant radiation emissions, potentially extending over vast distances. The sheer magnitude of such radiation raises concerns about the survival of Earth and our solar system. While Earth is situated in the Orion arm of the Milky Way, approximately 27,000 light-years away from the galactic center, this off-center location offers some degree of safety. However, the outcome ultimately depends on the angle and speed at which Andromeda collides with our galaxy. Current estimates suggest that the two galaxies are approaching each other at a speed of about 110 km/s. However, uncertainties remain regarding the final trajectory and speed of the collision. Simulation models depict various scenarios, ranging from the Milky Way being pulled into the center of Andromeda to a side-to-side merger of the two galaxies. Each scenario carries different implications for the fate of our solar system. If the galaxies merge from the side, gravitational effects may disrupt the spiral arms of the Milky Way, potentially flinging our solar system into intergalactic space or destabilizing its orbit. Such disturbances could have profound effects on Earth's climate, weather patterns, and ozone layer, exacerbating global warming and introducing new environmental challenges. Moreover, the chaotic interactions between the myriad components of galaxies, dust, stars, dark matter, and other celestial objects will be intensified by gravitational forces during the collision. This upheaval could lead to significant disruptions as stars and planets shift out of their orbits, ushering in a period of cosmic chaos and transformation. As new clusters and superclusters form and gases mix in potentially hazardous ways during the collision, our solar system will undoubtedly be impacted. The release of radiation and various gases from these reactions could lead to the deterioration of our atmosphere, posing threats to habitats and biodiversity. Allergies, pandemics, and other health issues may arise as a result of these changes. If the two galaxies collide head-on, center to center, there is a possibility that our solar system could be drawn into the mega black hole at the center of the newly formed galaxy. However, this scenario is less likely, and regardless of the outcome, we cannot escape the consequences of the collision.
Yet, there is a chance that we may witness the cosmic spectacle unfolding before our eyes. We might see new constellations and stars emerge in the sky, replacing old favorites like Betelgeuse. However, these cosmic events unfold over vast timescales that far exceed our human lifespan. The collision could take several million years to complete, and by then we may no longer be around to witness its culmination. It will be up to our descendants to navigate the challenges posed by this cosmic event.
The accelerated timeline revealed by the James Webb Telescope underscores the urgency of studying and understanding this collision. Scientists are diligently working to monitor the progress of the collision using simulations and advanced instruments like the James Webb Telescope. They aim to unravel the mysteries of this cosmic wonder and prepare for its implications. As experts continue their efforts, discussions about naming the newly formed galaxy have already begun. Proposed names like Andromeda have surfaced, although no official confirmation has been made. Nevertheless, NASA scientists are committed to studying and tracking this ongoing collision, offering insights into the dynamics of galactic interactions. Thank you for watching this episode. Be sure to explore more mind-blowing videos like this one by clicking on the screen.